today we're going to begin Unit 7 in Algebra 2. So this is Unit 7, Lesson 1, and today we're going to learn how to convert from standard form of a quadratic equation to vertex form of a quadratic equation. And we've talked about the different forms before. Standard form is y equals ax squared plus bx plus c. Vertex form is y equals a times x minus h squared plus k. We dealt with this back in the first unit when we were talking about transformations. Your h and k is your vertex, and the a determines whether that function is wide or narrow and determines whether it goes up or down. If a is positive, it will be a parabola facing up. If a is negative, it will be a parabola facing down. Or positive a is a concave up and a negative a is concave down. You could think of it that way as well. So we need to learn how to go back and forth between these two forms. So that's the first thing we're going to do. This chapter is going to be dealing with graphs of quadratic equations, and one of the first things that you need to understand when dealing with the graphs is when it's best to use which form. And so one of the things we have to do first is learn how to go back and forth, and then we'll be able to talk about which form helps you do specific things. Like standard form is usually the best form if you want to find the roots, but if you need to figure out the direction and the vertex form would be the best form to use. So it's very important that we understand the uses of each of these forms. Here it says y equals x squared plus 6x plus 11. When we're dealing with quadratic equations, the y, it can either be equal to y or f of x. It doesn't really matter. And understand that if we're finding the roots, we're going to set it equal to 0 to do that. But now what we're going to do is we're going to get this into vertex form, or y equals a times x minus h squared plus k. And to do that, we're going to use completing the square. But we're going to use completing the square a little bit differently in this one. Since all of our numbers for this, we have the y or the f of x on the left-hand side by itself, all of the numeric values are going to be over here, and all of your variables that involve x are going to be over here on the right-hand side. So I'm never going to do anything with the left-hand side. That will be equal to y no matter what. And the first thing I'm going to do is I'm going to group my first two terms in my quadratic equation. And if the coefficient of the x term is anything other than 1, I need to distribute that out. In this case, it is 1, so I don't need to do that. But what I do need to do is rewrite this, leave a space there because I need to complete the square here, and keep the constant term on the outside. That constant term is going to help us develop the k value. The term inside is going to help us find the h value. Now, in order for this to be in vertex form, notice this has to be a perfect square. So how do we make something a perfect square? We do that by completing the square. So we're going to complete the square here. Remember, to do that, we take half of 6. Half of 6 is 3, and then we take 3 and we square it. So 3 squared is 9. This is going to be a plus 9 right here. Now, there's a problem with just adding a plus 9 and leaving it and not doing anything else. We have changed the value of this equation by adding 9 to that equation. So we have to offset that. We only are allowed to add 0 to one side of an equation. So if I add 9 here, I need to offset that so that I'm really just adding a 0. So if I add 9 on the inside, I'm going to subtract 9 on the outside, so that really all I've done is add 9, subtract 9, I've added 0. I'm making it look different without changing its value. We've done that a lot with different things already this year. So now I'm going to factor this. I've got y equals x plus 3 squared, and 11 minus 9 is a plus 2. I have accomplished what I needed to do. This is now in vertex form. If you think about that, my a value is 1, so that tells me the parabola is going up. My vertex is hk, it's x minus h plus k, so my vertex for this is -3, 2. There is no number other than 1 here, so it's going to be the regular width of the parent function of the quadratic equation. Right now, that's really all we can do with this. We'll learn more about this as we go throughout the chapter and how to graph. Here's another example. We want to put it in vertex form. I'm going to leave the left-hand side, f of x. I'm going to group the first two again. I'm going to rewrite it, leaving a little space for the completing the square, and I'm going to keep the plus 11. To complete the square, I'll take half of 8. Half of 8 is 4, and then I square that number to put it right here. So I'm going to add 16 on the inside. If I add 16 here to offset that and force it to be a 0, I'm going to subtract 16 out here. Then to write it in vertex form, there's nothing there, so that's understood to be a 1. If I factor that, I've got x minus 4 squared. And if I add those together, I have a minus 5. So here, my a value is 1. I know that's a parabola that goes up. My vertex is going to be 4, negative 5. That means it's going right 4 and down 5 from the origin to start the vertex. In this one's a little bit different because we've got an a other than 1 now. So it's going to change what we do just a little bit, same method, but there's one extra step that we have to think about when we're writing this in vertex form. So I'm going to start it out the same way. I've got f of x equals, and I'm going to group again the first two. And after I group those two, I have to realize the x squared term has to have a coefficient of 1. So that is not 1, it's a 2. So I have to take the 2 out of the first two terms. Now, I'm not going to take it out of the third term. We will deal with that later. You'll understand why in a minute. But it's a lot easier if we just take it out of the first two terms. So that's what I'm going to do first. I'm going to take out the 2. And then I know I have an x squared minus 4x left. I'm going to leave some space for completing the square, and I'm still going to have a plus 9. Again, you do not take 2 out of the 9. We will deal with what happens there in just a few minutes. I'm then going to complete the square. I'm allowed to do that because the coefficient of the x squared term is now 1. Half of 4 is 2, and 2 squared is 4. So I'm going to add 4 here. Now, it might be tempting to take the 4 plus 4 and do a minus 4, but we can't do that. Because now there's a 2 on the outside. Remember in the examples before, that always had a 1. So we didn't have to do this next step when this coefficient was 1. But now that it's a 2, think about what we have really added here. We haven't added a 4. Haven't we added a 2 times 4 or 8? So we've added an 8 inside. So that means on the outside we have to subtract an 8. So that we've really only added 0. We're just changing what this equation looks like. We're not changing its value. If we were to distribute it back in, we would have a 2x squared minus 8x. But look at what we have here. When we complete the square, half of 4 is 2, and 2 times 2 is 4. 2 squared is 4. What we've really added is an 8. Since we've added 8 on the inside, we have to subtract 8 on the outside to offset it so that we've really only added 0. We have not changed the value of this equation, we've just made it look different. And then I'm going to finish with my factoring here. I keep the 2. I have x minus 2 squared, and 9 minus 8 is plus 1. So looking at this, my a value is 2. It's a positive 2, so the function is going up. The vertex here is a 2, 1. So that means we're going right to up 1 from the origin to get to the vertex of that parabola. Notice again, there's a coefficient in front. I'm going to do the same thing. I'm going to group the first two. I'm going to take out the negative 2. And that leaves me with x squared plus, because I'm bringing out a negative. Now, let's think about that. That's a 1. If I divide 1 by 2, remember taking a 2 out means I'm dividing each term by 2. So if I divide 1 or -1 by the -2, isn't that going to give me a plus 1/2 there? So I have a plus 1/2. I'm going to leave some space, keep that plus 6, and that'll be a plus 1/2 x. And then I need to figure out what I'm going to add here. Well, half of 1/2 is 1/4, and 1/4 squared is 1/16. So I'm adding a 1/16 right there. I can't forget then, what have I really added? Well, I've really subtracted a 1/8. -2 times 1/16 is 1/8, a negative 1/8. If I've subtracted a 1/8 on the inside, I need to add a 1/8 on the outside. So you see how this gets a little difficult with the fractions, but that's okay. It's still, we do it all the same way. So we have y equals -2. This is going to give me x plus 1/4 squared. And then the 6 plus 1/8 is 6 1/8. You could also say that's 49/8. Again, you can use a calculator for all of this computation. You don't have to know how to do this in your head. Use the calculator, that's just fine. So in this one, here my a value is a -2. So that means this parabola is opening down. If this number is not between 1 and -1, it's going to make our graph more narrow than the parent function. Vertex form is x minus h, so our ordered pair for the vertex will be a -1/4, positive 6 1/8. So from the origin, we would go left 1/4 and up 6 1/8 to start our vertex. And then that parabola would open down. So here's another example. I want you to see if you can complete the square and put this standard form equation into vertex form. So pause the video, see if you can work through it, and then I'll go over it with you in a minute. First, I group the first two. I factor out a 4. That leaves me with x squared minus 4x. I leave some space, and I put the plus 2 on the outside. Half of 4 is 2. 2 squared is 4, so I'm adding 4. But what I've really done is added 16. So that means to offset it, I need to subtract 16 outside. So my vertex form of the equation will be 4 times x minus 2 squared minus 14. My a value is 4. It's very narrow going up, and my vertex is at 2, -14.